Suhas. Hello.
Yes, sir.
Hello. Anyone, you can unmute yourself and tell me, are you able to see the screen and audible?
Yes, sir.
Rahul, Pritam, can you listen?
Yes, sir. We can listen.
Hello,
Yes, sir.
Yes,
Yes,
sir.
sir.
Pawan.
Yes, sir.
Pawan,
Yes, sir.
Pawan, unmute yourself.
Yes, sir. Unmute ಮಾಡಿದ್ದೀನಿ.
Can you listen?
Yes, sir.
Hello,
Yes, sir. You are audible, sir.
hello,
Yes, sir.
unmute. Pawan, unmute.
Yes, sir.
Can you see the screen?
Yes, sir.
Hello,
Yes, sir. ಕಾಣಿಸ್ತಿದೆ ಸರ್ ಸ್ಕ್ರೀನ್.
So the screen is
hello.
not visible, sir.
ಎಲ್ಲ ಕಾಣಿಸ್ತಿದೆ.
Hello,
Yes, sir. ಕಾಣಿಸ್ತಿದೆ ಸರ್, ಕೇಳಿಸ್ತಿದೆ ಸರ್.
ಕಾಣಿಸ್ತಾ ಇದೆ ಸರ್.
ಸರ್ ನಾವ್ ಹೇಳೋದ್ ನಿಮಗೆ ಕೇಳಿಸ್ತಿಲ್ಲ ಸರ್.
Rahul.
Yes, sir.
Hello.
ಸರ್ ಎರಡು ಕಾಣಿಸ್ತಾ ಇದೆ ಸರ್, ಸ್ಕ್ರೀನ್ ಮತ್ತೆ ವಾಯ್ಸ್ ಎರಡು ಕೇಳಿಸ್ತಾ ಇದೆ.
ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ? ಸರಿ ಸರಿ, ಓಕೆ ಓಕೆ. Last class we discussed about the measurement of screw threads. There will be two types of threads. One is external thread, other one is internal thread. Again, you have one more classification, that is left hand thread and right hand thread. The difference between the left hand thread and right hand thread is all of you know. In some of the components, for example, you have mixie in your jar. In that, if you turn the nut in clockwise direction, it retraces. That is called left hand thread. Suppose if you turn clockwise direction, the nut advances on the bolt, then it is called right hand thread. In all engineering drawing, they specify by the letters. Say in the drawing, if they mention LH, letters LH, then it is called left hand thread. Otherwise, it is considered as right hand thread. Next, come to the point. That is the difference between left hand thread and right hand thread. The first right hand thread. If you turn the nut in clockwise direction, then nut advances on the bolt, then it is called right hand thread. If you turn the nut in clockwise direction, if it retraces the path in the opposite direction, it is called left hand thread. So different types of threads are available. First one, for engineering applications, we use V thread, and Acme thread, buttress thread, and again the threads are classified into again two. One is metric thread, other one is British thread. They usually in British thread they use a module, but in case of a metric thread we use a letter M18. For example, if you write M18, that indicates the major diameter of the thread is 18 millimeter, and M indicate it is metric thread. So we are following international standard, that is a metric system, that is M18, that indicates the metric system. Then come to the point, terminology of screw threads. So this is a very important in third module. Very first question is, explain briefly with a neat sketch the terminology of screw thread. Terminology of screw thread. See, all of you observe here. This is the terminology of screw thread. This is the external V thread. External V thread. Say the major components of the threads are, first one is major diameter. Say if you touch the circumference of the thread, you feel the sharp edge on the surface. That's the major edge. Major edge, or that is called major diameter. Below that, there will be a triangular shape, that is, all of you observe here. There will be a flank which is connected at a point and which make an angle, that is called thread angle, which is called thread angle. This is very much important for producing threads on the component. Say the threads angle are classified into like this: 30 degree, 45 degree, 60 degree, 75 degree, and 90 degree, like that. Depending upon the type of application, you can use the thread angle. The major element of the thread are major diameter, minor diameter, thread angle, flank, and addendum and dedendum. Say above the axis of the thread is called addendum, below the axis of the thread is called dedendum. And next, very important, the angle. So how much angle you can produce on the thread, that is very important. Usually we can produce the V thread easily by using lathe machine. That is, you can cut the thread by using the carriage, lead screw, and you have a little calculation for thread cutting that you understand in the machine shop while cutting the thread on the component. So that's very important. Say in the examination, you have to write minimum 5 elements for 10 marks. Before that, you have to write the diagram of the external thread. All of you observe here. This is the bolt. You have to produce the threads on the component by using lathe. See, it looks like a triangle, and there will be a peak point on the thread. The distance between the two peak point is called pitch. Remember in your lifetime, that is, the two peak point on the thread is called pitch. Remember, the two peak point on the thread is called pitch. So these are the terminology of profile or the terminology of screw thread. Next, come to the point, the types of screw threads. Say, first I told you earlier, V thread, unified thread, British Association thread, Whitworth thread. Like that, you have lot of international standard threads are available. Depending upon the application, you can cut the thread on the component. Next, you come to the point, very important. All of you seen the screw gauge. In the screw gauge, you can find the 3V thread. But in case of all of you seen, in case of lead screw of the lathe, so there you have to use the square thread, and also you have acme thread, buttress thread, like that. Say if the force or the load is very, very high, then you can go for the square thread. You can see in the lead screw of the lathe, there you have the square thread. And very, very important, all of you seen, many of you already used the screw jog. Screw jog, the lifting of the vehicle when the puncture happened to the tire, you have to lift the car. For that reason, you are using the jog, screw jog. So in that screw jog, you have screw on the screw jog. That screw, that is the thread that is in the form of square shape. So square shape threads are very much important where the load or the force are very, very high. Say, in the metrology lab, how do you measure the major diameter, minor diameter, addendum, pitch of the thread? So for that, we have the caliper, screw thread measuring caliper, or you can fix the thread of the component in the two anvils of the screw measuring instrument, where this is the cylinder and this is the anvil. You can fix it in between the two centers. Then all of you observe here. So what are the things you have to measure for minor diameter? I'm not asking about major diameter. This is the minor diameter. All of you observe here. That is the R2. The bottom portion of the thread you can measure by using the anvil provided in the instrument. You can observe here. These two anvils are automatically, you can fix the distance between the minor diameter. One is stationary, just to pull the anvil and place it on the screw thread and see the dimension, that is R2. The diameter of the cylinder is S. The micrometer reading over the standard cylinder is R1. All of you observe here. Then the reading of the anvil, two anvils making and contact with the bottom portion of the thread, that is R2. Hello? Hello? ಹೇಳಮ್ಮ ಈಗಾಗಲೇ ಆಮೇಲೆ ಮಾಡು. Then minor diameter of the screw thread D equal to S plus or minus difference between R1 and R2. R1 and R2. Available by using micrometer measuring anvils. By place the anvils like this, all of you observe here. This is the internal thread and this is the taper parallels. Keep it like this. From this also you can measure the minor diameter of the screw thread. Next, come to the point. Measuring the minor diameter of the component by using rollers. This is for the internal thread. This is for internal thread. So here you have to place the rollers in the bottom portion of the thread, and the center you can use the slip gauge that will give you the minor diameter of the thread. So this is very, very simple. First you place the roller in the minor diameter, that's in the triangle. In between use slip gauges. Slip gauges will give you the distance and the diameter of the roller will give you the total length of slip gauge plus diameter of the roller will give you the minor diameter of the thread. Next, come to the point. Screw thread pitch measurement. So you have experiment in the metrology lab where you can use the tool room microscope for measuring pitch. What is the pitch? First thing is, what is pitch? The two peak points of the thread is called pitch. How do you measure the pitch? Say for this, the instrument has two anvils. Keep the thread in between two anvils or centers. Keep the component of thread of keep the component in between the two centers, and all of you observe here, this is the screw thread, and in the instrument you have a stylus. All of you observe here the stylus can be pulled by using spring system. You can move the stylus in the backward direction and see the micrometer. There will be a provision that is the stylus is spring loaded and provided with the nut. So from that you can keep the stylus on the thread like this. That can give you the pitch that can be measured by using micrometer. All of you observe here the pitch measuring machine. So in this machine, there will be a provision to fix the thread of the component in between two centers, and there will be a spring loaded head is there, which is connected by the stylus. So you can pull the spring loaded stylus head backward direction, place it on the thread, external thread, that will give you the micrometer, that will give you the pitch of the thread in the micrometer. You can read the pitch of the thread in the micrometer. All of you listen carefully. If you present complete 45 minutes or 40 minutes in the class, you are in connection with the class, then only it is considered you are present. Otherwise the attendance is absent. Just connecting the class and leaving the class in between, that will not considered as the present. For that reason, you have to join the class as early as possible according to the time as per the timetable, and you have to be present minimum 40 minutes. After that only it is considered you are present. The Google Classroom is designed to consider if you present more than 40 minutes in the class, then only it is considered as you are present. Otherwise, it is absent. All of you, please write your name and USN in the chat box. USN in the chat box. Say here, in this software, there is no involvement of human being. Everything is programmed, and this is automatic attendance retrieval system. So we cannot change the attendance manually. Everything is programmed, and if you are present in the class, then it is considered as you are present. Otherwise, by joining, by leaving in the middle or in the before 40 minutes, it is considered as absent. Once again, the pitch measuring machine. Say this, in this machine, you have two centers. In between the center, you can fix the workpiece of the thread. component of the thread. Then there will be a pointer in the head, and there will be a spring loaded stylus head. You can pull down the stylus head and place the stylus on the thread. So all of you observe here, this is the pointer K and this is fiducial indicator. Here you can measure the pitch of the thread. Pitch of the thread in the micrometer, while if you are moving the spring loaded head with the stylus, there will be a rotation in the micrometer that will give you the pitch of the thread. Pitch of the thread. Say in laboratory, you have 3-wire method and 2-wire method for measurement of elements of the screw thread. 2-wire method and 3-wire method. Wire means it is not wire, it is the shaft. It is the shaft, and there will be an anvil which is fixed like this. All of you observe here. 2-wire means it looks like a micrometer. In the micrometer, you have 2 anvils. One is stationary, other one is movable. So first select 2-wire method or 3-wire method for measurement of profile of the thread or terminology of the thread. The profile means effective diameter, that is major diameter, minor diameter, addendum, dedendum, flank, thread angle, and other elements of the thread you can measure by using 2-wire method or 3-wire method. You have this experiment in the metrology lab. You have to select 2-wire or 3-wire. Wire means it is the shaft. Wire means it is the shaft which is fixed to the anvil. Which is fixed to the anvil. So all of you observe here. This is the screw thread and this is the wire and this is the anvil. Before measuring the screw thread or terminology of screw thread, you have to select, you require 2-wire or 3-wire for measurement of thread. Measurement of thread. So for that reason, which method, 2-wire method or 3-wire method, which method is best? For that reason, you have a simple derivation and calculation that you have to carry out in the lab before conducting an experiment, that is measurement of screw thread. That is effective diameter, that is nothing but major diameter, minor diameter, angle of the thread, addendum, dedendum, and pitch of the thread that can be measured by using 2-wire method or 3-wire method. So in this case, 2-wire method, say we have 2-wire and also we have 3-wire. Which one is best for the measurement of thread profile? You can select. So for that, in this diagram, all of you observe here, you have selected 2-wire method and place the wire of the anvil on the thread like this, on the wire like this. Then measure the minor diameter, major diameter, and the distance between the 2 wires. Distance between the 2 wires. That is the T equal to M minus 2D. D is the diameter of the wire, and M is the dimension over the wires, and C is the constant value depending upon diameter of the wire. Then all of you observe here, this is letter E, T, and first draw the profile of the thread like this, and the diameter of the wire is D. the distance between the two peak point is pitch, that is letter P, and the angle of the thread is theta. Half angle is theta by 2. Half angle is theta by 2. How do you calculate the angle of the thread? For that reason, you have the equation OA equal to OB. All of you observe here. OA equal to OB into cosecant theta by 2. Cosecant theta by 2. Then, by substituting the values of diameter of the roller and the angle of the thread, you can measure the thread angle. You can easily understand the measurement of angle while conducting the experiment in the laboratory. OA equal to OB into cosecant theta by 2. Then, substituting the values in the equation, you will get the angle of the thread. Next, come to the point, measurement of measure diameter. See, the equation is there for the measurement of the thread angle. The same way you can use the diagram and calculate the angle of the thread. So in this example, the angle of the thread is theta equal to 55 degrees and the constant is 0.9, P minus 1.1657 D. So in the metric, so Whitworth thread means it's the British system. The angle of the thread is 55 degree. From the calculation, you can calculate the angle of the thread is 55 degree. The same thing of the metric thread, theta equal to 60 degrees. Say the one more method. From that, you can measure the internal thread of the component. You can measure the pitch of the thread, major diameter, minor diameter, and other components or other elements of the thread by using plaster of Paris. All of you observe here. So you can keep the nut or the component in between the two wooden blocks like this. In the center, fill the gap between the two blocks, fill with the plaster of Paris, liquid plaster of Paris. Leave it for 1 minute or 2 minutes. The plaster of Paris dries up and remove the casting or mold from the internal thread, and you can measure the effective diameter, major diameter, minor diameter, pitch of the thread, and also addendum and dedendum by using the molding method, making a casting of the internal thread by using plaster of Paris. Say, now I stop at this stage and I will continue in the next class. And all of you, please write down your name and USN in the chat box.